Hello. Ladies and gentlemen, all protocol observed. I greet you and welcome you to day 4 of this training. For those who are joining us for the first time, this training workshop is on geospatial techniques and productivity monitoring, and it is an outcome of the Land Productivity Assessment and Methodology project that was implemented under GMES and Africa program and RCMRD. The aims of this training is to empower participants on how to assess and monitor land productivity using Earth observation tools and QGIS-based plugin. So we thank you all for attending this training, especially those who have been with us right from day 1 till now. A very big thank you to our facilitators for sharing relevant knowledge. To Makerere University, RCMRD, GMS and Africa, thank you for making this training possible. Today,
recording in progress.
Today is day 4 of this training, and the program is a bit loaded. We shall start with a recap of day 3 training by Mr. Paul Magaya, and that should take us from 14 hours to 14:30. Then Professor Majaliwa, our lead trainer, who took us through the soil estimation, is going to come and conclude that module. And he'll also tell us how they came up with the tool. We shall have the trainer of the day, Mr. Katwere James, who is going to introduce the land productivity tool, data requirements. He's going to tell us about data requirements, model interface exploration, data entry and processing, and then how the results from the model are interpreted. We shall have Dr. Barasa Bernard, the team leader, the technical team leader, to explain the results or statistics from the tool, from the model. And then we will end up with a closing session, which will take 30 minutes. So before I invite the first, I want us to have this, take note of the following. We have a training evaluation form, and the link will be shared soon. We thank those who have already filled in, and we appreciate your assessments and your feedback. I request that as we register today, for those who are coming in for the first time and have not been with us the previous sessions, like day 1, day 2, and day 3, please register for today by indicating your actual names, the actual names, your title, if any, if applicable, and then the place of work or institution. In the Zoom chat, we'll be able to capture those details. And for those who have been with us since Monday, please just indicate your name for us to know that you have already also attended day 4. Those details will help us as we prepare the certificates of attendance. The training materials, dear participants, are posted on different mediums. When you go to Google Classroom, you'll find links to the Google Drive where they are posted. And links are always shared out on new emails, and you can still get them via Google Classroom. Let us keep our mics mute at all times, unless it's your turn to talk. And for questions, I'm requesting that we utilize the Zoom chat and the Google Classroom options, and also build on the discussions, if possible. At this moment, allow me, dear ladies and gentlemen, to invite Mr. Paul Magaya to give us a recap of yesterday's training. Paul?
Thank you so much, Chair. My name is Magaya Paul. I took you over yesterday's training, which was data download and processing. Just a moment, let me share my screen. Yeah, data download and processing. But since we are limited on time, I'll just go through, and my concentration maybe it will be on how to use the Modus GUI interface and how to download the data that we used, and the data that we used, and I'm going to give the data that I'll use as an example will be Uganda. But however, the sample data was also uploaded for Kenya or different media, Google Drive and the mails. So, however, before that, we went through how the processes how this data was downloaded and how did we come to it, and we made differentiations of different data sets and how the data also is captured. So the process of interpreting and accessing this data is called remote sensing, which we said is the science of monitoring the information of an object without getting into physical contact with it. We gave a live example of humans, how themselves are remote sensing gadgets, and we gave an example of maybe a flat tire and a blade. The moment these two sounds occur, one can easily identify that that's a bullet and this is a flat tire. So that sense of interpreting is already remote sensing. The picture that you get to know that is a flat tire is the interpretation, and so that's how the remote sensing gadgets, the scientific remote sensing gadgets like satellites, that's how they do the interpretation. So we said there are a number of gadgets, how these pictures are captured, the images, and we said there are Earth observation satellites that are installed into space, and they move around the Earth to pick the images in order to process maybe the temperature and the environmental changes on Earth. And however, some cameras are also installed on some aircrafts so that it can pick some of the images for analysis. As you can see, we showed that some of these cameras, that's where they are installed, and we showed also how the images are captured when maybe the element is maybe above the ground. We also said there is also a sonar system that is also installed on some of the water vessels, that are installed beneath the water vessel, so that it can monitor anything that is below the water surface. And sometimes these gadgets can also help to analyze the route, the vessel's route to and from, whereby it will be using waves to communicate maybe the distance to and from before the vessel reaches the obstacle. So we gave a live example, an illustration on how these gadgets, like the Earth observation satellites, how they capture these images. They rotate around the Earth. That orange circle is the path where the satellite gadgets, how they move around the Earth. And this brings to that the faster the satellite gadget moves around the Earth, the better the temporal resolution. So this brings us to one of the attributes of attributes that are considered before a particular type of image is considered for processing, which one is the spatial resolution and the temporal resolution. The temporal resolution we are talking about, the time of the satellite it takes to revisit the starting point is the temporal resolution. You'll find that some of these images, the temporal resolution is between 1 to 2, 1 to 5, some of them have 8, others 16. So any image which has at least 1 to 2 could be having a temporal resolution. Then the spatial resolution, we also said that this is the number of pixels utilized in constructing an image. So meaning the more pixel an image has, the more accurate the image. So for example, the first image is 30 meters, the second is 100 meters, the third is 300 meters, meaning that the one with a lower number has more details than the one with a higher number. So here, don't interpret the resolution as that the higher the number, because it is big, meaning the higher the resolution. So it is just vice versa. So we also managed to highlight on some of the satellite sensors and the images they produce. Currently, these are some of the images that are used for research purposes. We have the Landsats, the Modus, Sentinel-2, Equinox, and others. So here we are to compare the spatial resolution and the temporal resolution and maybe their status. So you find that Landsat, you'll find the temporal resolution is 8. So this means that the satellite takes 8 days to come back to the point where it started from, and Modus has 1 to 2 days, satellite 5, Equinox 3. But remember, however much the resolution is good, first look at its status. It may be good, as you see, Equinox and others like Worldview. The resolution will be good, less than 1 meter compared to the other images, but it is commercial, and such images are very expensive. So before you decide on an image, first of all, to carry out a task, first of all, look on which image can you afford and which image can bring out the output according to the task. So you have to balance between the spatial resolution and the temporal resolution, the status, but another factor, the scope. How big can this image cover the area of interest? You'll find that one might have a good resolution, but you'll cover a smaller area, yet you have a bigger area. So all these factors have to be put to considerations. We also looked at how this remote sensing data can be applied in everyday life. We looked at how marine environment can use the remote sensing data. We showed you how the marine vessels, how they capture this data and how useful can it be, whereby it will be tracking its movement, atmosphere and climate. It will also be helping predicting the weather, the emergency response. We talked about the different disasters like flooding, earthquakes, a number of them. Fire management, you can predict areas, you can find areas that have been burnt with fire, and also maybe predict the future areas that can be affected by fire vis-a-vis using the GIS tools. Hydrological modeling, here using also the remote sensing data, you can delineate out watersheds and you can also calculate the size of wetland in a particular area. The land management, you can also calculate the changes in land cover according to different trends, maybe 3 years or 2 years. You can also use the vegetation status using different indices to know how healthy the vegetation is within a particular area. Here we brought in the number of indices that can be used. We talked about the NDVI, which is the normalized difference vegetation index. We talked about the survey soil adjacent vegetation indices, and we talked about the MV, enhanced vegetation indexes, and also we outlined when can any indices be used. We said that if you don't want soil reflectances within your output, please use survey. And I also emphasize that we use survey here because we already have the soil data which is going to be put together within the calculations. So there was no need of making a repetition, and we zeroed down to survey because it will remove the soil reflectances from our output. We also said even under land management, there is also crop phenology. Using this report sensing data, you can know the start and the end of the growing season of a particular crop. So being the fact that we zeroed down to survey, so we said however much we zeroed down to Modis, but at least you can use the different data, maybe Landsat, Sentinel, MODIS, to extract out survey from any of the desired images of your choice. And we gave the different formulas and also gave a reason why we decided on survey, because it has a finest temporal resolution among all the images. So we went ahead to show how the survey can be downloaded. We said survey can be downloaded from the sister sites like Earth Explorer, Earth Data, Glovis, but we zeroed down to Earth Explorer, and this is the link. This is the link. When you go direct to it, we illustrated how we can download MODIS data, and we saw the limitations of concentrating directly to the MODIS data vis-a-vis the tool that we used, in that the tool will download the bulk of this data at once, process it, reproject, resize, and mosaic it at once, unlike data which is downloaded directly from Earth Explorer. So this is the tool that we used. This is MODIS TSP page, which is embedded into the ARA package. And this is the link. If at all you don't have the ARA software, this is the link to download it. When you click on it, it will take you directly to the page of the setup. So download it and install it. Then after downloading it, we summarized all the packages that might be needed at a moment to build the GUI interface of MODIS TSP. The GUI interface, which is on your right, is not direct the way you see it. You have to first feed the ARA console with all these packages so that to build the GUI interface. And the last codes down here, 13 and the 14, these are the codes that at least check if the MODIS TSP GUI interface has been successfully installed. All these packages have a use, and they have a reason why we should install them before the GUI interface works. So we put the reasoning, which are in red. The moment you finish installing all these packages, then you can come and check the library. If it is successful, then you put the command to open the GUI interface. We say the GUI interface will open in a new browser, any browser of your choice. It will pick by random, and this is how it will appear. So I think we shall start from here, depending on the time. I have more 15 minutes. We try to open the GUI interface using the ARA console. Then we go through how to download it. I already have the downloaded data, but at least if you go through the process that I'm going to use, you'll be able to download the data and process it. Unless there is any question in 1 minute, so that I can continue.
Yeah.
So meanwhile, let me open the ARA. Yes, please.
I can't see any question coming in.
Okay,
Please continue.
Let me continue, please.
It's trying to change to another.
So when you open So I'm sorry, I had a call. Please, participants, as per now, don't call me. I'll handle you after. So when you open our ARA software, this is the ARA console that will appear. So we have these, we have all these configurations. They have been shared. So you just copy the ARA library to check our ARA. So the moment you paste, if at all there is no error, yeah, you see there is no error, then you type MODIS TSP. The problem with this language, it is case sensitive. You type in small letters, it will not work. So I'm waiting for it to open. Then I'll share. So that's how it will look like. That's how it will look like. So we said the first, when we look at on your left, we have the menu, we have the products and the layers. Under products and layers, you go to products category. You look for any category that has vegetation indices, which is this ecosystem variable vegetation indices. The moment you click that, it will also recategorize more products under vegetation indices. When you look at this, we said a higher resolution is better. Since we are dealing with the modules, let's compare the resolutions that we have. We have 500 still big. 1 kilometer is still big. 0.05 is big. There is 250 meters. So go for 16-day, 250 kilometer. This is the product code, MODI 13 QI. Even if you don't look at the resolution, but make sure you look for MODI 13 QI. So MODI 13 QI is under water and land. So first of all, you have to also confirm under the platform, which platform are you selecting? Terra means land, aqua means water. Our interest is on land. So you select land, which is Terra. So it will give you the selected layers under MODI, vegetation index 16 days, 250, MODI 13, QI. These are selected layers that you can process out of it. So under the layers, we have the NDVI that we usually know. If you're told you need NDVI, maybe you're not interested in survey, you just click this and then continue. Don't click anything. But if you're interested in MV, you go for this. So this tool does not only work on survey. At least there are other layers that can be processed under this tool. But our interest here, there are other spectral indices that can be worked upon. There is a flood index. If at all you want to know the flood index of your area, you just come on, you get the same data. But our interest here is survey. You click on survey, and this is the formula that will be used in the background. So you go to Spatial and Temporal. So here you select the date of your choice. Yesterday I selected 2019. You can use 2019, January, first day of the year, 2019. I also need 2019. If I want 2019, you can even download 2 years at a go, but it will also take time because now you're downloading 2 years. And the advantage it will leave as it is downloading, it will separate these 2 years according to the folders. So December 31st, we'll follow the December 31st. Yeah, good. So the projection, every country has its own projection. I'll user defined. Then say change. The moment you say change, my case study will be Uganda. Rwanda, I know it is 36 south. Sudan is Rwanda is 35 south. Kenya, you can use 37 north, anything like that. Are you able to hear me? Hope so. Then when you click OK, it will request on what area of interest, as you can see the map here. So you can either select the tiles of your choice, depending on the country of your choice. But here it will tell you to move the world map to your area of interest. If you say bounding box, you have the data. You have to just click, load data, then browse your area of interest. So your administrative boundary has to be ready on your computer. Mine is on the desktop. Is under C. Then I look for desktop is under users, all you HP, then desktop, training, districts. This is where my administrative boundary. Then I'll point to a file with SHP. So if you have internet, it will directly overlay itself in the area of interest. So thereafter, I'll go to output format folders. Then you put your your username and password. Remember, this output is going to be this Explorer, Explorer Globis Any. So remember, these sites have the same password and user. And the moment you register on one site, you'll have the same password to use either. So mine is Magaya2, my username. This is my password. So then output format is GeoTIFF. We have ENV and GeoTIFF. I prefer using TIFF because it is the format that can be read by most of the GIS softwares. GIS softwares. The rest, ignore. So we go to our output main folders. So after processing, the computer is asking us, after processing, where would you like to save your work? So after processing, I want to save it on the desktop. You can create your folder under training. Under training. Training. Then I'll go up to Uganda survey. I've already created these folders. Then the year is 2019. Then I'll put it under. Then I'll go to 2019. The processed data will be under TIFF. Then I say, okay. What you see on your right, this is the folder that will be created by the folder when it is downloading. Then I select, okay. Then there are files that are processed to get the final data. They are called modules HDF. This is the large code data format. These files are big. They are not projected. They are not mosaiced. So the program has to download them. Then it does the processing on them. Then it saves the output in the TIFF folder. So I'll also select where I want to save them. It will be under desktop still, training, Uganda, 2019 is the year of my. To my side, I saved them on my computer because I have the space, but I won't show you a tactic if at all you don't want to save them because they take a lot of space. Those files only may be around 30 or 40 GB. The new computer. That means after using them for processing, then they are deleted from your computer. The computer will ask, do you want to delete the HDF file? When you say yes, that means after using them, they will be deleted. If you say no, they will be saved in that folder. Then they are used for processing, but they will be retained. But so where you're saving it has to have RAM. If you have internet, as you click that, it will be downloading in the background, as you have seen. It has gone off, but it's downloading. So maybe I have to do the downscaling of our processed data. Chairman, hello? Hello?
Yes, Mr. Magaya. Hello? Hello, John Paul. Maybe he's off. Okay. Dear participants, just to know that all members of the technical team are on board. The lead trainer, the lead of the technical team, the data analyst, the system developer, they are all on board. So whichever questions that you have, please don't hesitate to post them either here or in the classroom. But you can even do both. You can post them here and still post them in the classroom. They are going to attend to those questions. They're going to be, your questions and concerns will be addressed. So please get there, and whatever you feel is not well with you, please raise it. Secondly, I thank you very much for those who are registering for today's attendance. in this chat. Thank you. We are capturing these names and the details. Again, I want to remind you that we have a training evaluation form posted. I think I'm going to request someone to post the link again here. We need to get your feedback. We need to get your feedback that will help us improve in future. Also get those recommendations that you make, that you want us, or that you want to make about this training. Today we are just recapping. Some people are wondering why are we having the same stuff that we got yesterday? Yes, today is a recap. That is why all the technical team are all here. The members of the technical team are all here. Remember, on the first day we started with the concepts, definitions, understanding how to estimate soil productivity, who were given assignments to do. Day 2, we went through the QGIS, the tools that we use to understand and display data. Day 3, okay, day 2 we are also given assignments. Day 3 we are also, I think we got assignments, and I think he's trying to emphasize on the assignment that we got. So people who have assignments to submit, I'm glad that some people have already submitted their assignments and they are being assessed by the facilitators. Thank you very much. Today is a recap, actually. We are just recapping. We are just recapping because Professor is coming on next to, for those who really took his assignment seriously, you'll have a lot to get from his 30 minutes presentation that he's going to make. And if you have it somewhere, please look for it and let it be somewhere on your desktop. Today also we are having the system developer who will come after Professor. He's going to show us how this tool that was developed works. So he's going to show, I'm sure everybody has the link where that data for today was posted. For those who don't have, please, I can have, let me, by show of hands, those who haven't accessed today's data, please put it in the chat so that I know and we take appropriate action. Otherwise, I can see a hand raised. Someone help me to, unmute yourself, please, and raise that concern, a question or whatever. Frederick, come on. Unmute Frederick. Okay. Is there any other person? Paul is back. Frederick, please. You can talk, Frederick. I don't know whether you can hear me or not.
I'm back. This is Paul.
You're welcome, Paul, John Paul.
Is it okay to continue?
Please do.
Okay.
John Paul?
So,
John Paul?
yes, please. Yes.
Kindly mark
yes,
that time.
yes,
mark that time.
How many more minutes are
you
5. Giving me, please?
Please
okay, just go to
utilize 5.
Mm.
Please utilize 5 minutes.
Okay, please.
Okay.
Okay, please.
Thank you.
So the last presentation, which I showed you how to download and to the extent of the data which is pre-processed. So let's try to add the data which is processed. so that we can calculate the average survey. So we shall go to layers, layers, because they are raster format, shall select raster. My data is in training, trained all at once, and we shall add it into GIS. So when you look at the results of our data, they are out of range of the values of NDVI. So the NDVI range is between -1 and 1. Downscale it by multiplying it by 0.0001. All we shall use the raster calculator, as you can see. Then you click one by one, multiply 3. This is a lot. We multiply by 0.001. Just of time. Let me try to be fast. I'll just read only the numbers. Plus 17 plus 33 plus 49 plus 65 plus 81 plus 97 plus 113 plus 129 plus 145 plus 161 plus 177 plus 193 plus 209 plus 225 plus 241 plus 57 plus 73 plus 289 plus 305 plus 32521 plus 337 plus 353. So we can check. We can put the brackets. We shall close by using brackets because we need to divide. We shall also have to open at the beginning. Then we shall also divide by 23, since there are 23 images. Division on our calculator is that, then type 23. So you see our expression that it is valid. If there is any error, it will be invalid. So we locate where we want to save our output. I've already created this folder, still under 2019, my average. Then because it is not yet rescaled, we shall put it under unscaled. This is the output for yesterday. So when you replace it, I'll just say OK, then run. It will give you the output. So when you look at our output is 2019 survey unscaled, we are going to divide it by 0.001 so that we get the NDVI range. So still we shall use the raster calculator. Raster calculator. Our target is 2019 survey unscaled. Times is the star 0.101. Then close the bracket. Locate where I want to save as our output. Our output is under rescaled. So this is our rescaled. Let's call it to put just to differentiate it from yesterday. .tif. Save and run. As you can see, the values are different. In our layer layer panel. Due to the interest of time, maybe let me just, after getting that, you must, using the administrative boundary, have some data set that is outside the administrative boundary of our area of interest, which is Uganda. As you know, Uganda will never exceed in the west, and also some parts of Kenya are also taken. Let me just add the administrative boundary of Uganda. We look at it, then we say I enter. So this is under administrative boundary. Just here we have a copy. If you add Kenya, you would put Kenya. If you add Rwanda, you would put Rwanda. Add. So as you can see, there are some parts outside Uganda. The next step here would be mask.
Hello? Hello, John Paul? Hello, John Paul? So in the interest of time, I am requesting you, dear participants, to allow me invite the next facilitator, Professor Majaliwa, to recap, or not recapping, but you remember first day we got an assignment to estimating soil productivity. So he's going to conclude on that and also tell us how they came up with the tool. I want you to join me.
You'll get the final output, then you change color so that you can easily interpret your survey of a particular content. Due to the interest of time, this will be practiced by.
Okay. Thank you very much, John Paul. So I hope you have concluded now. Hello, John Paul. Okay, now, Professor Majaliwa, please, I'm requesting you to take the mic, unmute and take us through this session.
Okay, thank you, moderator.
Participants, thank you.
For allowing to start. Yes, Paul, I think you need to unmute now.
I give the floor back. Yes, I've already closed.
Good afternoon to everyone. Good morning for those who are still in the morning. Bonjour, bon après-midi à tout le monde. The other day, we started with the concept and we left a small homework. This homework is basically to assist understand how the tool works. So for the interest of time, I'm going to demonstrate for two parameters how it is done, how the calculations are done for two parameters. Then James will come in to demonstrate the tool and give results, and then Dr. Barasa will come in to summarize the different results which were obtained from the tool and their interpretation. So let me share the Excel file which we had shared with you. This is the Excel file. but also I shared with you a PowerPoint presentation, but also I think they shared again with you also the manual describing how the calculation was done. So I want also to, let me first remove this one and also show the PowerPoint if you don't have it. So this is a PowerPoint which we had shared with you with the exercise, and we said you had the soil of soil target region, an Excel file. This Excel file is basically the table of the map you have. Exported the table into an Excel file. So, and the instructions are very clear. You need to filter for your country, and you can compute for the factor rating for each of the parameters you have. And then toward the end, you can aggregate the different factor rating into a productivity, a soil productivity index. So, and that is toward the end. Then we had the exercise and the direction we wanted, the different guidelines we had given for you to do it for your country. So I'm going to go back, stop this, and bring back the Excel file. So this Excel file, as we said, we demonstrated last time, it has the name of the soil, the code for that particular soil, the country and its code, but also the area in square kilometers. Then you have the different parameters, sand, silt, clay, which were already aggregated into texture. And then a texture class type was already determined. So then you have the pH, organic carbon for the top and sub. You have nitrogen, base saturation, cation exchange capacity, the calcium, bulk density, and then you have the carbon nitrogen ratio, and then you have the name of the soil, and then the productivity given by FAO. So
Prof, we can't see the screen. We can't see the Excel sheet.
you can't see the Excel sheet.
It's
Let
not
me stop
displaying.
again and try to display it again.
Okay.
Is it now? Can you see it now?
Yes, thank you.
Okay, so now, so this Excel sheet has all those parameters. Yeah, those are the things sometimes. Yeah, there is a space here. I've seen it. Now I think it should be fine. It should be fine. Just a minute to. I know it is still refusing. There should be one extra, another thing which had happened.
Hello, doctor.
Yes, go ahead. Yes, go ahead.
If actually the equation, when you're looking at it and the equation is okay, I think the problem is you need to go to that AP up that cell a bit, because sometimes it's just that the figure can't fit. And so
no, I think this one.
If the equation is okay,
be,
okay.
The equation is fine, but I think it may not be. It may be seeing this one as a number, not as a letter than instead of being a number. Let me again try to format the cell and see. Yeah, it is actually a number.
Professor, I think in the last string where you say if AC2 is greater than or equal to 40, you're missing out the equal sign.
No, even if I had not, I can put it back. Even if I have not put it, it could have come. There is see. Why is it? It should have come. It should have come.
Prof, could you try with SC3?
We can try it with AC3, but if we have not yet, if we have not solved the issue, it will still be an issue here. It will still be an issue. Let me try to copy this on a different Excel sheet. Let me first try to copy it in a different Excel sheet and see what happened. Now let's do systematically with one and see what is the problem really. Okay, so let me see if AC2 is less than 5, give it 20. Otherwise, give it 0 and see what happened. No, I think there is a problem with the Excel. There is a problem with the Excel. Let me redo. I'm going to copy it on another sheet and save this as values. So 1 minute stop for that. I can do it outside.
I'm drinking someone. You're doing my work?
I'm doing that GIS.
That is good. I think you're somewhere there. Can you now import your return?
I can do this.
Meanwhile, dear participants, let's utilize the tool 1 minute while Professor is fixing the formulae and whatever he's doing. And we fill in the evaluation.
No, Margaret, I've tried it outside. I've tried it outside sharing. It is working. But when I share, it does not work. I don't understand.
Sorry about that.
Yeah, but basically, we have been using a if function to actually put the factor rating. And once you have done for the different factors using the if, we have the different factor rating, then we create an aggregated index where we put those, in this case, 7 factors together. And then we use again the factor rating for the productivity to do it, to actually get the final productivity. And that's the formula. Those formulas were also done in ArcGIS. So let me suggest that James comes in, demonstrate the tool. I will work in the background to bring the different formula. Then when he finishes, I can bring it out again.
All right. Thank you very much. We hope to get back to you, or we hope to have you back in this training after this session of that day. So we apologize, dear participants, for that. I think it's a technical hitch. So once he fixes it, he'll get back to us. At this moment, I want to invite the system developer or modeler, Mr. James Katwere, to take us through the tool, its interface, how do you enter data, how do you process it, and how you interpret the results. So over to you, Mr. Katwere James. Hello? Hello? Unmute, please. You seem to be muted.
Is muted.
Hello? James, please unmute. Unmute the mic.
Okay, if he's not yet ready, I can show to the people because I've done it outside.
Okay, that's okay, Prof.
I've done it outside. Yes, I've done it outside. So,
okay.
So what I've done, basically, I think it is an issue of sharing. So I've put the same formula and put for CSFL. So I put if the AC2 is less than 5, we put 20. If it is less than 20, we put 50. If it's less than 50, we put 75. There should be a 75. Add 35. And if it is less than and equal to 40, is 100. So that's exactly what I have. So it changes automatically, and I can copy the formula downward. If I've done it for this parameter, you go to another parameter. For example, the next parameter here on the estimation is organic matter. So I'm going to take the values for organic matter. So if it is less than 1, we have 20. If it is between 1 and 2, we have 50. If it is between 2 and 5, it is 70. And if it is greater than 5, we have 85. And if it is over 25, So if it is greater than 25, it's 100. So I'm going to do it in the Excel sheet. I hope this time the computation is going to be done inside here. So I call it OM, factor rating. So I'm going to look for where OM is. Organic matter. So here we have organic carbon. We don't have organic, but we know the relationship between organic carbon and matter. So I'm going to create another column where I'm going to say sum. We know that soil organic matter is 1.7 times organic carbon. So I'm going to take the organic carbon where it is, the topsoil. Okay, so I have the organic carbon, which I'm going to copy the formula. And then I can use now the if function. If this organic matter is less than 1, we give it 20. If it is less than 2, we give it 50. If it is less than 5, if it's less than 5, we give it 70. If it is greater than 5, we give it 85. And if it is greater than 25, we give it 100, and then otherwise we give 0. So those are how many, if I think 1, 2, 3, 4. So, and those are the 4. I should have been 5, okay. So it has now worked, so I can get 85, and then I paste it down. So we do it for all the parameters. You compute all the different factor rating for the different parameters. And once that one is done, then you can make an aggregated, the aggregated productivity, the land productivity index, and then you reclassify based on the criteria which was given. So I think that's enough to demonstrate how this thing is done, and you can do it for the other parameters. If there are questions, I'm ready to answer them. Otherwise, James can take over.
Thank you very much, Prof. Thank you so much for taking us through those highly scientific explanations and the computations. Participants, you have like 5 minutes to raise questions. Joseph, you have a question?
I think I have a question.
Yes, please go ahead.
I want him to show me on the formula of depth because it is not working for me.
For the formula of depth?
Yeah, the next one, depth. It is not working for me. I'm getting the error. Error entitled like hashtag name and question mark.
Yeah, because now for depth, it has to be in bracket. So you make sure that you don't have any space. Once you have space in it, it's going to bring a problem. So let me say put depth. Depth factor rating. Okay. If you go to the formula of depth, since it is since it is a text, you need to put that class in bracket. Did you do that? Hello? Did you put the class in bracket?
Yes, I copied the formula.
Now he's not responding anymore.
And I pasted it in Excel, but it didn't work.
Okay, so let me do it. Yeah, I will do for one. One of them.
Yeah.
And then share. I think the issue may be you need to cross-check if there is no space in it. So if this one, A is equal, because now it is equal, and then you have to put those columns. Type the way it is. So if you don't type the way it is, it will bring problem. Okay? So if the depth is deep, let me check the factor rating for that one. If it is deep, it is 50. Okay. If it is very shallow, it's very shallow, it is 20. If it is shallow, it is 3. If it is fairly deep, it is 50 also. No, deep was 85. Deep was 85. And then if it is very deep, it is 100. Okay, I'm going to enter that one. Okay, so if it's deep, it's 85. If AO, let me get even this bracket. If AO, equals fairly deep, if it's fairly deep, it is 50. If the same is moderate deep, we need to check if there is space or no space. If there is no space, we'll put, we remove that one, remove the space in there. So moderately deep, I didn't have moderately deep in my class. What did I give it for moderately deep? The one I noted here. Moderately deep, maybe it's also 50. We put 50, I think. I've left that one. Moderately deep is 50. Very shallow. If it is shallow, then it is 3. And then if is very shallow, so it's a matter of, you don't have to, you have to make sure that you copy the way it is, or cross-check, and then it's very shallow, it is 20. Otherwise, you give it 0. But it has worked for me. So cross-check if you really wrote it properly. So whatever you have put, make sure that it is actually what is in the cell. So I think the rest can be done. If James is around, take now, he can take you over the productivity. If the problem persists, it may actually be you need to copy, like the way I did, copy the entire sheet to a new sheet. Okay, and then you can do the calculation.
Brian had a question. I don't know, Brian, is it a short one?
Yes, the short one.
Yeah.
Prof.
Brian can ask.
Yeah, Prof, I just wanted you to assist.
Yes.
Maybe you talked about it to explain how you come about these factor rates and why they vary for each parameter. Maybe you talked about it, but I just wanted to understand that.
Yeah, these have been published by different authors. So we aggregated all those factor rating as they have been suggested by the different authors.
Okay, thank you. It's gotten.
Yeah. Thank you very much, Professor. I now invite Mr. James Katwere to take us through the next session. James.
Yes.
Hello.
Yes, greetings, everyone.
Yeah, okay.
I'm James Katwere. I was the software developer for the land productivity analysis tool. So, sorry. The tool was meant to implement the model that the professor took you through on Monday. I think everyone can see my screen. It was developed as a QGIS plugin. And if you are aware or remember what the facilitator on Tuesday, Dr. Barasa, took you through, QGIS uses plugins as an extension to the native functionality inside QGIS. These are distributed via QGIS plugin repository. Downloadable through the QGIS plugin manager. I'll take you. I'll do a small recap on the interface, how you can access the tool, how you can access the processing toolbox. Inside QGIS. And after an introduction on the interface, I'll show you how to download it, install it, and locate it inside the processing toolbox. And after that, we will use the data that is shared to you on the Google Drive. On the Google Drive, it's in the folder for Day 4, Introduction to the Prototype. And data inside the folder, it's for the whole IGAD region. Those are 10 countries. But all participants from your respective countries, the workshop was meant to facilitate you with each of your country's data set so that you can practice as an exercise. But we will follow on that up later. All those particular data sets will be uploaded each in its respective country folder. But in the meantime, I'm going to take you through how you go about executing the plugin. So I hope everyone can see my screen. I have QGIS opened. I use...
Just slide, James.
Yes, please.
Please give us a slideshow. Go into slideshow.
Slideshow. So I'm not getting you. Slideshow. Yes, please. Yes. So hope everyone can see.
Okay, it's called presentation mode. Presentation mode.
Oh, no. Finish with the slides. Now I'm into QGIS. I'm going to go ahead with the demo link. Hope everyone can see the QGIS interface. Okay. So inside QGIS, on the main menu, we see options for plugins. Under plugins, there is manage and install plugins. So the land productivity analysis tool, sorry, this was an earlier, you can either search it by its name, land productivity. Actually, the search tool filters through. You can search it by name. You can search it by the author or the provider, that is RCMRD. As you can see, mine is already installed, but on your side, since yours isn't installed, you click on the install button. The install button, mine shows uninstalled because it's already installed. And after installation, you'll be shown a successfully installed bubble. Depending on your internet connection, this can take a minute or two. So in order to follow what I'm doing, I'm going to give you a minute so that yours too can So I would like some feedback on that. If any of you has faced any problem installing, but in case there wasn't any error or any problem, internet okay?